This is the third video for chapter 5.2. So we're moving on to talk about sinking funds. So this is related to the ordinary annuity that we have talked about. So sinking funds is another important application for annuity formula. So this is an account that you set up for accumulating money over time to meet some kind of future obligation or debt. The sinking fund payments or the deposits is defined to be the amount that must be deposited into an account periodically to have a future amount. So it's really similar to, it's closely related to the ordinary annuity formula. Last time we need to find the future values and it's given payment to you. This time you know the payment or deposit amounts and then you need to find the future value. So reading the question, you need to figure out like what's given to you and what are they asking in order to pick the correct formula, right? So looking at number 5. So number 5 say, experts say the baby boom generation, so people were born between 1946 to 1960, cannot count on a company's pension or social security to provide a comfortable retirement as their parent did. It is recommended that they start to save early and regularly. So in addition to their pension and social security, they need their own saving for retirement. So Beth is a baby boomer, has decided to deposit $200. So deposit $200 each month. So this is obviously to be a periodic payments or what is that called? Deposits. So for 20 years into an account that pays 7.2% compounded monthly. So because this is not a lump sum of money, so it's not going to be simple interest or compound interest. And even though it's compounded monthly, but because of the periodic payment, so we will use the formula that we have for this chapter. So they want to know how much money she will have in 20 years at the end of 20 years. So it means they are looking for future value and it's given the payment, right? So I need to pick the formula that is trying to find, so we need the formula that's trying to find future value when it's provided payment, right? So let's write down that formula for my number 5. A. I didn't include 5B because it's finding interest, and they say you can do trial and error or using a graphing calculator to graph it. So we're going to focusing on the major skills this semester. Alright, so we have over here the formula say future value equal to payment 1 plus R over N and T minus 1. I always write down the formula and I would suggest you to do the same when you take an exam. So in case something go wrong, I can still give you some partial credit, right? So let's write down what we know. We don't know future value yet. We know the payment is going to be $200 a month. And then R is 7.2%. But I need to change it to decimal number 0.072, and then the N is going to be monthly, meaning 12 times a year, and then the T is going to be 20 years. So using all this information, why don't you go ahead and plug it in and see if you can find the answer. Okay, when you're ready, you can check with me. So we got $200 and 1 plus 0.072 divided by 12, and then weighs to 12 times the years for 20 years, and then subtracting 1 or 2 at the end, divided by 0.072 divided by 12. So I would highly recommend you to try it out on your calculator. You need to practice to make sure you know how to do it before the exam. So pull out your calculator. I would do it like in smaller steps. Some of you are very good with calculator, may be able to plug the whole thing in. So if you're very good with calculator, I would say set it up and give me the answer. That would be okay. So I'm going to do this fraction part first, which we have 0.072 divided by 12. I hit enter. I need to plus 1 here. I need to raise it to a power, which is 12 times 20. Let me write one more step for you. So 200, inside here we have 1.006. 12 times 20 means I have to compound this 240 times, or this person will make 240 payments totally. Subtracting 1 at the bottom, 0.072 divided by 12 is 0.006. So earlier I made the mistake and put 1.006, and I can tell the answer is not correct because it wasn't reasonable. So next I'm going to do at 1.006 raised to my 240 power, enter. I need to subtract 1, and then I need to divide by 0.006. So it means my $200 need to multiply 533, and then don't round it until the last step, right? So I'm going to just keep that number in my calculator. So dot 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 mean I'm not like getting rid of those decimal places, but times 200. So I should get an answer that is 10675. Oops, sorry, why did I do that? 106,752 and 47 cents. Okay, so that's what she will have in her account for retirement if she put in $200 a month every month for 20 years with all those interests. So this is the money in account after 20 years. Okay, so that's number 5. Are we okay? So for number 6, it's a sinking fund payment. So we're going to need to find payment this time. For Beth, in example 5, believe that she need to get $130,000 in the 20 years periods to have enough retirement. So she only saved up to 106,000 something, right? She think this is not going to be enough. She won 130,000. So this is the future value. For the 20 years period, this is your time to be enough to retire. To meet this goal, she must increase her money payment. So we don't know this, like what payment should she make each month. So we are using the condition from last question. So the R would be 7.2% compounded monthly, right? So the difference between that is for number 6, we don't know the payments, and we have the future value. So this one we are given future value. We are going to find payment or periodic deposit, right? So if you look at those formula we have, the one allow you to find payment when you have future value is this, right? So we're going to write down the formula. and then I'm gonna ask you to plug in the formula. So this is number 6. This is given future value, found payment. So the formula say payment equal to future value times R over N. This is my R, okay? And over 1 plus R over N and T minus 1. So we release the things we know. The future value, we don't know payment, right? Future value is 130,000. R is 0.072, just like the last questions. N is 12 because it's monthly. And T is still 20 years. So what I want you to do is like pause the video and then try to plug it in. When you're done, you can check with me. Alright? So hopefully you got it. And then this say payment equal to 130,000. And then this is going to be 0.072 divided by 12. 1 plus 0.072 divided by 12 weighs to 12 times 20, subtracting 1. So I'm going to use my calculator. 0.072 divided by 12, we should already know this is 0.006. Divided by 1.006 weighs to 12 times 20 was 240. We did that last question, like that. So hopefully you know how to do it on the calculator. We're gonna have 0.006 divided by parenthesis 1. I'm sorry, need one more parenthesis. 1.006 weighs to 240 minus 1 close parenthesis. Oh no, sorry. 0.006 divided by parenthesis 1.006 weighs to 240, and then I need to move the arrow on the side so the subtracting 1 would not be in the exponents, right? And then close the parenthesis. So it should be this really long decimal number, so 130,000 times 0.001873 and something, right? I need to leave that number there. Don't round it until the very last step. So I have that on my calculator. I just need to multiply $130,000. So my payment, instead of $200, I need to waste it a little bit more. That's going to be $243.55. But you have to be careful. It says $243,554, right? I really shouldn't round it down, because if I round it down after these 20 years, it may not be able to reach this 130,000 goal. Normally we round it to 55 cents, right? But if you only put $243.55, when it go up over 20 years with the compounding, it may not reach our goal of the future value. So I would say this one you should round it up a little bit just to be safe. So round up to make sure reach future value of 130,000 in 20 years. So this is my monthly deposit. Okay, so that's number 6. With the sinking funds, you're funding the payments. Alright, So the very last question on your handouts is a little bit different. So remember the ordinary annuity, you make those payment or deposit at the end of the period, right? So if it's monthly, you make it at the end of the month. If it's like yearly, you make it at the end of the year. So this one is the annuity due. Is slightly different. So this particular one, instead of making those payments at the end of the period, is going to make the payments at the beginning of the period. So that makes things a little bit different. So let me write it down for you. It said the annuity due, instead of making payments or deposits at the end of each period, compounding period, it make deposits or payments at the beginning of each period. So if you think about that, if you make the payment at the beginning instead of at the end of the month, your money is going to compound one more time compared to the regular formula, right? So they made the formula a little bit different. So the future value of annuity due, so the regular formula would be future value equal to payments 1 plus R over N and T minus 1 over R over N, right? And this annuity due, the difference is they're going to add a 1 here, because if you put the money in at the beginning of the period, it's like you are going to compound it 1 extra time. Okay, so that's the only difference for the annuity due, and I think you have homework questions like that. That's why I want to show you one example. But on the test, we probably will go with the ordinary annuity because those are more popular. You will see that more often. But let's look at number 7, which is the last question for this section. This one says, found the future value of an annuity due. So annuity due means they will compound 1 extra times if the payment is $500 made at the beginning of each quarter for 7 years in an account paying 6% compounded quarterly. So this payment of $500 is made at the beginning of each quarter, meaning they given periodic payment, right? So that's not a lump sum, so not regular compound interest. And we're going to use this formula that with payments 1 plus R over N and T, but you need to add 1 more compounding period, minus 1 over R over N. Alright, so and then we're going to list the things that we know on the side. So we have payment. Let me put the question up. Okay, payment is $500 each quarter, right? And then we don't know the future value, and we also know R is 6%, which means 0.06, and then this is quarterly, and is quarter, So 4 times a years and t equal to 7 years, right? So we can use that to plug it to our formula. You can pause the video and check the answer with me if you want to. 500 1 plus 0.06 divided by n is 4 raised to 4 times 7. 4 times a year, 7 years. But don't forget to add one more compounding period because you deposit the money at the beginning of the period, and then 0.06 divided by 4. So using your calculator, I'm going to need 0.06 divided by 4 plus the 1 is 1.015. So I'm going to have 500 1.015. This is raising to 4 times 7 is 28 plus 1 more is going to be 29, right? I'm sorry, 4 times 7, 28, yes, 29, right? So 29 here, and then minus a 1, and then 0.015. Alright, so go ahead and finish that, and we're going to check it. Let me double check my answer is correct also. Okay. So if we plug into that formula, we got 1.015 raised to 29 power. Enter, subtract 1 divided by 0.015. So this number need to multiply to 500, right? So 500 multiply 35.9987 and keep that decimal number. Hit enter. Our answer should be about $17,999.35. So that's what you will have in the account after 7 years. So this is a annuity deal, which you put money in at the beginning of the period, and the only difference is you add one more compounding period. Okay, so that's the end of chapter 5.2. We're going to assign the homework on my math lab. Okay.